So I happened to catch something interesting yesterday. We were testing a 377 amp drive for a refrigeration compressor. That's a big drive. And this is what happens on the output of the drive. You got your PWM. But what happens when you disable the output of the drive, this is what comes out of the motor. Okay, so let's talk about that. So the motor is rotating, it's connected to the drive. The drive's turning it to the PWM, and then you shut the drive off. So why does this happen? It happens because here's your motor. SJ de Watt took this image. It comes from Wikipedia, so we attribute this to him. It's a three-phase motor, a squirrel cage motor, an induction motor. So there's your stator, here's your rotor. You've got your iron rotor with your rotor bars that go through it and the shorting rings on the end. So when the motor is running, you've got magnetic energy stored in here. And when you stop supplying magnetism from the stator, this magnetism in the rotor doesn't immediately disappear, this energy, because you've got the shorting rings on the rotor bars. When that magnetic field starts to shrink, it induces current in the rotor bars, which causes current to flow, and therefore you still have magnetism. So the magnetism decays slowly when you shut off power to the motor. Because you have magnetism and your motor is spinning, it acts as a generator. And that's exactly what happens here. Is the motor actually generates voltage on its output as it spins down to a standstill. This lasts for about half a second to a second. It depends on the physical size of the motor, how much iron mass you've got in the rotor over here, and therefore how much energy you've got stored in it. The bigger the motor, the longer this will carry on. So that's very interesting what you see on the motor terminals when you shut off the drive. You see it actually working as a generator briefly. So that's what's going on there. It's motors and inverters or variable speed drives as we know them. This is something we see in our line of work, but not many people get to see, which is very interesting. So I thought I'd share what we saw yesterday when we were testing that big drive, 377 amps. It's a 400 volt drive. That's why you see the DC bus sitting at 540 volts or 560 volts peak while the drive is running. But your motor voltage, the RMS voltage, is actually 380 volts. That's why this sine wave is less than that peak voltage of the PWM over there. That's your DC bus voltage. That's your motor AC voltage. And also the current in the motor windings actually looks like this while this is happening over here. And I think that's it. I happened to see this on the scope and I took a photo and I thought we'd have a talk about it because it's very interesting. And that's going to wrap up a little talk on what happens to an electric motor and the energy in it when you shut off power to it. The answer is it briefly generates voltage, but it only lasts about a second. It's quick, then the energy is gone, especially if there's nothing connected to the motor terminals. In this case we have some lamps connected to this as well, which do draw a bit of current, but not much. They're 150 watt light bulbs. So only a little bit of power there. And the motor that we use is a 27 amp motor. in this case for testing. And to do the full current testing, we use inductors as a load. Then we can draw full current, and we can get the IGBTs and diodes on the output hot and check that all that stuff is good. So we're going to end it here. Thanks for being here, ladies and gentlemen. Take it easy, have an awesome day further, and we'll see you back here next time for more fun stuff. Cheers.